In this video, I will talk about measures of variability. So you want to see how much variability in your data. Here we have an example. You have two columns or two funds, Fund A and Fund B. Each has 20 years of annual payout data. Fund A consistently paid $1,100 every year. Fund B varies each year in payout amounts, ranging from $100 to $2,500 per year. The average annual payout of these funds is the same, which is $1,100, but they're not equal funds. So by just looking at the average, you can't really get the big picture. You need to also look at the variation. In the case of investments, more variation means more risky. So then the risk has to come with rewards. And if it doesn't come with rewards, you don't want to take the risks. So you would choose Fund A over Fund B because Fund A is not that risky. It seems to consistently give $1,100 each year. So this histogram shows the distribution for both funds. For Fund A, you basically have one bin, which is $1,100. And for Fund B, you can see different bins with different range of values. One of the measures of variability is range. Range is basically the difference between the minimum and the maximum. So, for example, the maximum home sales price in 1 year is $456,250, and the minimum is $108,000. The range of the values would then fall between these two numbers, and so the maximum minus the minimum, which is $348,250. So basically, the higher the range, the more variability you have. So another popular measure of variability is called variance. The basic idea is how much the value deviates from the mean. So the way it's calculated is by calculating the difference between each value and the mean. So x bar is the mean and xi is each of the values. So you can calculate the deviation of each value from the mean and then add them up and then divide them by the sample size n-1. So that's what we call the variance. The higher the variance means there's more variability in your data. The population standard deviation is different from the sample standard deviation. So in the formula for population below, mu is used to represent population mean instead of the x bar, which is for sample mean. So in this formula, the capital N is used to show the population size rather than the small n, which is used for the sample size. So if you use samples, you divide by sample size n-1. If you use population, you divide it by the population size with the uppercase N. So here's an example of calculating variance for a small sample of 5 values. So the mean of this sample is 44. And then we're going to subtract the mean 44 from each value, and then you square each of these values, and then you add up the square values. And after that, you divide it by sample size minus 1, and the result is 64. So the variance is 64. A more popular measure of variability is standard deviation. Standard deviation is basically the root squared of variance. So in the previous example, variance 64, so the standard deviation is square root of 64, which is 8. So, and the standard deviation is a common and major measure of variation, so you can use very often for your data. So again, for the sample, S squared is sample variance, and then the S is sample standard deviation. So for the population, it uses sigma instead. Another measure of variation is called the coefficient of variation. So if the standard deviation is 1,000, how do we know if it's high or low? You really don't know, since this is just a number. It becomes much more meaningful if you can compare it with the mean, or if you calculate what's the proportion of the mean it is. So that's what we call the coefficient of variation. Coefficient of variation is basically standard deviation divided by the mean. So you want to see what percentage of the mean it is, and so multiply by 100 to make it a percentage. And that's the coefficient of variation. So here is the 5 class sizes data again. The mean is 44 and the standard deviation is 8. The coefficient of variation then tells the sample standard deviation is 18.2% of the value of the sample mean. So now let me show you how to calculate this in Excel. Here we have the 12 years home sale data again. So to calculate the range, we will use the function maximum and minimum and subtract them. So we use max and then enter the data range, minus minimum and then the same data range. And so we can see that the range is 348,250. And for the variance, we use an Excel function called var. So we have var.s for samples, and we have var.p for populations. Since we have a small sample here, we're going to use var.s and then enter the range of data. So we have a variance, and that's very high. So next we have the standard deviation. We're going to use the Excel function called stdv and enter the same data range. So then the standard deviation is much smaller than the variance. It's 95,065. Lastly, we have the coefficient of variance, which is equal to standard deviation divided by the mean, which is equal to 43%. And that's it. These are the measures of the variability and how to calculate them using Excel.